But the questions of physics, these are universal questions. It's about the nature of reality, right? It's about how everything works well beyond Earth. The questions are bigger than Earth. And so it's tempting to imagine that they're also being asked by people off of Earth,
Yes.
right? And that when the aliens come, we could talk to them about it. We could connect with them about it. And even more tantalizing, they're likely more advanced than we are, especially if they show up here on Earth. And so rather than just like hacking away at string theory for another 200 years, maybe we could, skip a few steps and actually get to the answer, because yeah, the process is fun, but we all just want to know.
What's up, you scholars of enlightenment? Dr. Sam Gregson, particle physicist here again. I hope you've had a brilliant week and have a fantastic weekend in store. Sorry, I've been away for a little bit doing lots and lots of shows internationally, US, Ireland. I'm back now, so let the content flow. Today we will be answering the question, do aliens speak physics? This is the question raised in a new book, out just this week in all good bookstores, so pick it up. In science fiction, physics and mathematics are regularly assumed to be a universal language, which we could use to overcome communications issues with civilizations far off into the cosmos. Alien and human scientists could stand at the blackboard and bond over the finer points of quantum mechanics or general relativity. But is this assumption true? Even if there are intelligent, technological civilizations out in the universe, would they understand our physics models? Would they formulate physics in the same way with fields, particles, potentials and interactions? And would they even value physics in the same way that we do? There are many ways in which aliens could do physics differently to humans, and those differences would frame any first contact scenario. So to dive deeper into that question, do aliens speak physics? I'm joined by the book's author, Professor Daniel Whiteson. Professor Whiteson is a particle physicist and a professor of physics at UC Irvine in the United States. He uses machine learning and statistical tools to analyze high-energy particle collisions in an effort to unravel the nature of matter, energy, and our universe. He's also the co-host of a podcast about our very universe and has co-written 2 popular science books and co-created an educational preschool television series on PBS. So, who better to help me answer the question? Do aliens speak physics? So, Daniel, first of all, welcome and congratulations on the book.
Hey, thanks so much for having me here. I'm really excited to talk to you about some aliens.
Exactly. So, tell us a little bit as we start about the journey. So, when you say, do aliens speak physics? Is this, can we understand them speaking physics? Is this, would they want to speak physics with us? Is this, do they have a different process of physics? Is it all of the above and more besides? And why did you decide to address these questions?
Yeah, it's essentially all of the above. Basically, the book is asking, when aliens arrive, can we have Daniel's fantasy, which is that we sit down with aliens and have an interstellar science conference.
I was a bit worried about what it might be then, but good. The conference, we'll go to the conference.
There's a lot of ways you can go with aliens and fantasy, but mine is a pure one. I just want to understand the universe. And, I got into this game, I got into physics, probably the same reason you did, is because I'm curious about the universe. I want to know how it works. And the reason that physics is so appealing to me is that it's supposed to be universal. It's supposed to describe everything in the universe. Like, biology is wonderful, but probably it describes stuff happening on Earth. Psychology is amazing, but is it really applicable beyond Earth? But the questions of physics, these are universal questions. It's about the nature of reality, right? It's about how everything works well beyond Earth. The questions are bigger than Earth. And so it's tempting to imagine that they're also being asked by people off of Earth,
Yes.
right? And that when the aliens come, we could talk to them about it. We could connect with them about it. And even more tantalizing, they're likely more advanced than we are, especially if they show up here on Earth. And so rather than just hacking away at string theory for another 200 years, maybe we could, skip a few steps and actually get to the answer, because yeah, the process is fun, but we all just want to know. If I could know the answer to the fundamental theory of the universe, I would love to just have that downloaded into my brain by aliens. And the appealing thing is, the tempting thing is that a lot of folks assume that this is something that we could do, that aliens are working on the same project, that if aliens show up, that it's physics we would have in common with them, that we could make this connection with them, that we could talk to them about the secrets of the universe. And anything that's so tempting, anything that's so seductive, and frankly, anything that puts us at the center of the
Yes.
universe, like
Yes.
human physics is the physics,
Yeah.
is something you should take a very careful look at.
Mm.
It deserves an extra dose of skepticism. And so
Because
this
we've
book,
fallen into that trap a few times in the past,
oh,
haven't we?
yes. Oh, yes. And so this book essentially says, well, what do we really know? Are we making a bunch of assumptions when we say that human physics is the physics, that we are essentially revealing the truth of the universe rather than revealing the way we think about the universe? Fundamentally, the book is asking, is physics universal? Is it discovered or is it invented? Is it a reflection, in part at least, of our human lens? And so, while it's a very difficult question and philosophy offers no hard answers, the book is an attempt to interrogate those assumptions and say, what do we really know and what are we just assuming because it's familiar, because we have only one example, and maybe aliens have taken a different tack? So, that's the question I wanted to answer in the book.
It's very interesting because I guess we see a lot, online on Twitter about people, saying aliens are here, the UAPs are aliens, but
Yeah.
not a lot about how we might potentially talk to them if they are here. It just seems to be a lot of, well, we'll meet them someday, won't we? Or it'll be revealed, it'll be disclosed that they're already here. But
Yeah. Well,
what's
in
the next
science
step?
fiction, you see a lot of it. Like if you watch Aliens Earth, there's an amazing scene where they tap out a few digits of pi and then the alien taps out the next few digits. And they're like, wow, brain connection, how we have the same, mental structures in our minds, which is awesome, but like totally unrealistic, that they would use like base 10 explanations of pi, or they would recognize this or this kind of stuff. So I think it's a common trope in science fiction, at
Yes, very
least,
much so.
that physics and math are universal, and that's the way we could communicate. And there are strong arguments in favor, but there are also strong arguments against, and there's no data either
Mm,
way. And so this is a case where, like, I think a lot of physics people or science people have strong opinions
yeah.
on a question that's really a philosophy question. And there are valid arguments on the other side. And again, no data either way. And so I think it's worthwhile to try to open up those assumptions and ask yourself, like, how do I really know this? Is this something I believe because I want it to be true, because it feels comfortable, or because I actually know?
You're right. This is very much an assumption in sci-fi, I guess, because the episode would be very boring if they just sort of, stared at each other, not understanding each other for
Right.
the entire. I mean, they all speak English for some reason as well, right? So, I mean,
Yeah.
we
Well,
sort of
the other thing that
suspend
always
disbelief.
happens in science fiction is when the aliens come, they just like throw them up on the screen, and there's no audio issues, there's no video issues. Things just work perfectly. And like, I can't even get that to work with humans.
Yeah,
The first 5 minutes of every meeting are like, can you hear me? Wait, let me unplug this.
yeah.
And you never see that in science fiction.
Exactly right. So, before we get deep into this, there is something I
Yeah.
kind of want to clean up, a potential confusion up top. So,
Mhm.
are you questioning the idea that the laws of physics are the same at all places and times, which is kind of very much an assumption we use when we project out into the galaxy? Or
Mhm.
are you just saying that the models that different civilizations develop to describe those objective underlying physical laws would be wildly different? Are you saying there's different physics that aliens might experience compared to us? Or are you just saying that we experience the same physics, but we might model it in a different way? We might use different mathematics. We might use a different framework to formulate.
I'm going to go with secret option C, because
Okay,
I'm not
good.
saying either of those things. So
False
you're right.
binary, good.
Yeah, I'm not saying that the laws of physics are different in Andromeda or in the other parts of the universe, that like the speed of light could be different,
Yeah.
or that F doesn't equal ma, or general relativity doesn't hold outside of our galaxy, or things like that. Because our model of physics, you're right, extends to the whole universe. Newton took us off the planet and into the heavens, and that works, right?
Yeah.
It's on one hand like an extraordinary act of hubris to say that our model of physics should apply to distant galaxies,
Yeah.
but we have data. We look at stuff
Yeah.
from billions of years ago, and the physics mostly works. I mean, there's obviously things to still unravel, but the idea that we are not in a special place, and the laws of physics we derive here apply everywhere is a strong and powerful idea, very well backed by data. So
Kind of
I'm not
helps us to make
suggesting,
progress as well. Without that assumption,
right.
we're kind of stuck in our little corner of the
Yeah,
universe anyway, aren't
yeah,
we? So we kind of have to
yeah,
make that
and
assumption to go outside.
that's right. And that's something we could discover. We could find a galaxy where, wow, the laws of physics don't seem to apply there. That's weird. And that would be mind blowing. And but we would have data, right? But no, and I'm also not saying that the aliens experience the same physics, but just describe it in a different language. I mean, that's possible. But I think in the book I go even deeper and I suggest that, there might not be a single explanation for the universe. There might not be an underlying objective truth that we are trying to describe in our language that aliens would also be describing, where you could have like a one-to-one mapping between our ideas and their ideas that are both describing the same underlying reality. That's an assumption. And it might be true, and it might be that way, and there are good arguments for it, but there are also important questions about how we know that and if that is really true. If there is really one single explanation for the universe, and if there is, in the end, even a law for everything that happens in the universe. And some of these things sound extreme, and the first time you hear them, you're like, "What? That's crazy." But you have to ask yourself, how do you know these things? And so I hope that we'll have a chance to discuss some of these weirder sounding ideas.
I think you mentioned a situation in I read your interview with Ethan Siegel, and you were talking about a tornado, and you keep making things more and more complicated, that modeling more and more complex systems. Eventually, we run into a limitation of what our computers can do or what our
Yeah.
analytical models can do. And how do you actually know after that point that physics continues to work in the way that you think, and it's
Mhm.
just a problem of computation? Maybe
Mhm.
the physics outside the things that you can model breaks down. You're making an
Yeah.
assumption that it doesn't.
Yeah. I mean, on one hand, we're in awe at the power of our physics, right? Like we can predict things to 9 decimal places, and then we can go out and do experiments and we measure them and it works. And when I first saw that, I had chills. I was like, oh my gosh, we're not just describing approximately what the universe is doing. We have revealed the source code. Like these laws of quantum field theory, this is what the universe uses to decide what happens to an electron. That's how I felt when I first saw that, because it's very powerful. Um, but we also know, on the other hand, that all of the laws we've discovered, they are effective laws.
Mm.
They're not fundamental. We don't think that the electron and the quarks and all these particles are the end of the game, that they are the final description of the universe, that they are, the bedrock of reality. We think that these are, maybe composite, but they're effective objects. We treat them as if they're point particles, but we suspect that there's more structure within it to explain all of the unexplained patterns in the periodic table of the fundamental particles, right? And so we know that these are effective theories, which means that they are approximate, even if they are accurate to 9 decimal places, and we can keep making them more and more accurate. They are in the end approximate, right? In the same way that like F equals ma is approximate.
Mm.
And the lesson there is that F equals ma is not a true story of what's happening in the universe. Like, why does the apple fall to the ground? It's not because there's a force. That story works and it's very effective, but it's not what's really happening. What's really happening is space is curved and apples follow geodesics, etc. And so, even though our laws of physics can be very accurate, it doesn't mean that they're revealing the story they're telling is always a true story about what's happening. And Nancy Cartwright makes this argument that there's always a place where your laws of physics can't predict because it's too hard, it's too complicated. There's always some place where chaos and turbulence and all that stuff make your laws irrelevant or unpowerful. Right? There's always a boundary to our laws of physics because they come with approximations and assumptions that we've built into them. Like the standard model is not valid past the Planck scale. If you asked me to calculate what happens inside a black hole, I couldn't do it, right? And no matter how much computing power I had. So because there are always regions beyond our ability to predict and test, Nancy Cartwright makes the argument in her book, The Laws of Physics, How the Laws of Physics Lie. Wow, bold title. That maybe there is no law there. Maybe what happens happens by hap. That's her argument,
By
or
magic.
that's her phrase. Yeah,
That's where the
and
magic comes in. That's the kind of.
yeah,
It sounds a
and
bit God
that
of the
is
Gapsy, but we are making an assumption
yes,
that the physics continues to
absolutely.
hold in that gap.
Absolutely. And it's very much physics of the gaps,
Yeah.
right? And but it makes you wonder, like, well, how do I know? Because if you were going to confidently state that the universe follows some laws everywhere, then that's a statement. And how do you back it up? Well, you can do experiments, but there are always places where you can't do experiments. And so, how do you know it follows those laws where you can't test it? Well, that's a philosophical assumption. And so, why is that relevant for the question of, like, alien physics? Well, we choose to do physics based on some assumptions and some approximations because we find that useful. So, we like find a patch of the universe that we can effectively describe using our laws of physics. Very cool. But it doesn't mean that aliens have to find the same patch. They could take on this big chaotic mess that is the universe and decide we're going to describe this other patch over there because that's interesting to us. And it could be that our patches don't like weave together into some larger truth. It could be that all we have in the universe are these isolated patches. Nancy Cartwright calls it a dappled universe. These little bits of understanding amidst, frankly, a sea of chaos where we don't know if our method of doing science can reveal laws that are useful. And anybody out there who's scientific is like, no, that's crazy. That's an affront to everything that's worked. And I agree with you. It feels very uncomfortable. But the point of the book is to ask, which of these things are we accepting because they're comfortable? And which of these things are we accepting because we actually know? If you want to apply your scientific standards to this, we don't have data in these areas. And so it's possible, right? You have to open your mind a little bit to the possibility that the universe could be very alien relative to our expectation. Because as you say, many times in history, the universe has insisted that it operates in a way that's very counter to our intuition. So our intuition, not a reliable guide for how things work.
Very interesting. So I guess the bottom line of this is what you're suggesting is that physics may not in fact be a true universal language that would allow us to get to the chalkboard with the aliens and work out what's going on, stand there and write the same sort of terms together and understand. It's the Tower of Babel here, and E equals mc squared might not necessarily help us.
Yeah, exactly. And not that physics is all a lie. It's just that we are seeing the universe through a human lens. And our humanity must have somehow distorted how we're seeing the universe or how we perceive it or how we explain it, or at least what we're looking at. And so the book explores like various places where our humanity can have distorted our physics, where, I mean, and maybe distort is too negative a word. Maybe there's some humanity in our physics. And so maybe we're not just learning about the universe, we're also learning about ourselves. And we can't distinguish, right? Because we have this one lens on the universe. We can't tell how much that lens has affected our view until we swap it out for another lens. An alien lens can help us triangulate what's really out there, if anything, that's true about the universe. And so on one hand, I'd love if aliens show up and it turns out, yeah, everything we've learned is basically true and physics is, the territory, not just an approximate map. And we can sit down or stand up at the chalkboard and like talk about Lagrangians and we're there. And that's amazing. That would be so fun. On the other hand, it might be even more fascinating if aliens show up and they're like, what are you guys doing? This is the wrong approach. We gave that up thousands of years ago. Turns out this is a much better way.
This is also something we see in sci-fi. I think of an episode of Stargate, my favorite sci-fi, and there's various, alien races turning up and saying, quantum mechanics, you think you can't measure the velocity and the position of a particle? Like, oh yeah, we got past that 500 years ago, and now we can walk through the wall, and you can't. It's
yeah, exactly. And in that case, we might learn something really fascinating about ourselves. About, oh look, why did we make this assumption? Or we didn't even realize we were assuming X, Y, and Z. What does that say about ourselves that we felt that way. And that's exhilarating, right? For the same reason that like it's really nice to go traveling and, discover other kinds of alcohol or like weird sweet pizza or whatever you discover when you're traveling. You're like, that's strange. Actually, I kind of like it. Or not. You don't have to like it, but at least it opens your mind to different ways to be in the universe. And so while I got into physics because I thought it was exciting and universal, it might be that in the end, it also tells us something about what it's like to be human.
And I mean, at the end of the day, this has potential practical applications, right? If we are going to meet the aliens, or we're going to communicate with the aliens, we are going to have to address these questions so that we can potentially communicate effectively. And we've tried to do this in the past with things like the golden plates on the Voyager. This was our first kind of hash at doing this. But this is also a practical question, hopefully, fingers crossed, when we meet the aliens.
Absolutely. And I think it's important that we think about this stuff before the aliens arrive.
Yes, so it would be preferable. So that we can either ask them for the phasers and the teleporters, or we can beg for our lives. One of the two would be useful.
Yeah, and this you have on the screen here. This is the Pioneer plaque. This is a great example of how tricky it is to remove humanity from our communications and from our science. This is what was put on the Pioneer probes, which was sent out into the solar system decades ago. And they asked Carl Sagan and his wife, and also I think Frank Drake, to describe a plaque to put on there in the hopes that some civilization sees it eventually and then learns something about us. And these were smart folks. I think they only gave them 2 weeks, so we're going to criticize them a little bit, but it's a tight deadline. And they understood, like, you can't just write in English, and you can't even just write math symbols. Like, what do you actually do when you want to communicate with aliens? And then they faced a very difficult problem, which is any idea you have in your head, you want to communicate to aliens via message, you have to encode it. You have to take it from the pure ideas in your mind and somehow represent it in symbols, right? I'm representing my ideas via these sound waves, or I could write things down, or I could do a dance. Every communication involves some kind of symbols. And the choice of symbols ultimately is arbitrary. There's no set of symbols which map back you only to one idea. Right?
You wouldn't expect the aliens to be using Planck's constant, or it would make absolutely no sense.
Yeah. And so when you choose a set of symbols, it reflects a lot about you and your culture and what you think makes sense. And in order to invert that, to go from symbols to ideas, you have to have that culture in common. You have to know what the encoding is, and you have to be able to recognize when you've done it correctly.
Even your senses, right? You even have to be able to see the damn thing in this case.
Exactly.
Do they see, or do they, feel vibrations around them, or whatever it might be? You even have to have a common set of receptors to be able to, analyze what you've received.
And so, like, look at the top part of this. There's a little depiction there, 2 circles. It looks sort of like eyeballs or whatever. I actually put that in front of a bunch of grad students here at UCI, and they're young enough to never have seen this thing before. And I asked them, what do you think this means? And, this is a very easy audience. These are biological humans with the same brain as Carl Sagan and physics grad students. So, like, they know this stuff. And nobody guessed correctly what this thing was at all. And what it's supposed to reflect is the hydrogen atom. And the line at the center is the proton, and the little line with a circle around it is the electron orbiting it. And the lines have directions, which represents a spin flip. And this is supposed to define a unit of time. So you're supposed to understand the one on the left is before and the one on the right is after. Yep. And the time for this process to happen is 1 unit of time in this diagram. And like, wow, that's very clever. But the chances that aliens are going to unravel that seems like basically nil, right? And I spoke to philosophers of language, and they suggested that without having some kind of context, culture, or like an alien to help you unravel it, there's almost no chance of being able to understand an alien message. And I'm a big fan of the SETI program. I love it. And Jill Tatar is fantastic. But I think they're right that it's basically hopeless. Like, even if we got an alien message, decoding it would require understanding something about how they encoded it, which reflects their cultural, ideas and history. And so I think that's why in the book I focused on the question of when the aliens arrive, because then we'll have like a physical context in common. We can like point at stuff and say coffee, donut, pizza, and we can build up a language from there.
We can do what they do on where is it? Have I got the example? We can do the old arrival thing where we point at things and human. Here is symbols for human, right? We can do that, whereas we can't with a
Yeah.
with a disembodied message that we
Yeah.
receive.
Yeah,
Excellent.
exactly.
Right then. So the book, the way that you structure it, considers a meeting with aliens, what it might look like, and what issues could get in the way of us being able to understand each other's physics. And I want to dive into some of those issues now. So one of the first questions to ask is, would we be able to understand how another civilization formulates their physics, which, seem to be suggesting that would be very, very difficult. So I think many believe that a kind of cogent description of our universe would need to contain some concepts like fields, particles, interactions, energy potentials, and the like. But these are human formulated concepts, right? So as such, any alien formulation of physics would have to just be a facsimile of the Earth-based formulation. You have these simple proxies, right? So we have quantum fields, they would have Canton Schmields or whatever you want to call them, right? All you have to do is map one onto the other, and you have to do this kind of Rosetta Stone, get the translations correct, get the language correct, and then everything will fall out. So first of all, are there potentially alternative ways of formulating, describing, and arriving at the same physics? You mentioned kind of Newtonian gravity and general relativity earlier. So I guess there are, even in Earth physics, different ways of arriving at the same answers with different formulations, right? And
Yeah.
therefore it's not unheard of. It's almost inevitable that the aliens would have a different formulation in their heads.
Yeah. On one hand, you'd like to think, look, there's a true description of what's happening out there because there's a truth out there. The universe is doing X, Y, and Z for some reason, ABC, that can be discovered. And we'd like to believe that. That sounds nice. But you're right. How do we know that there isn't an alternative theory of physics which works just as well, but is not just a mapping of our ideas into some alien language? Like it could be the aliens show up and they have, quantum schmields, and there's basically the same thing, but they use a different squiggle or whatever. And that would be incredible. That would tell us something really deep, either about the universe or about our common, way of thinking about it. But if 10 aliens show up and they've all independently come up with quantum fields, and that would be powerful.
Yeah.
But we're not there. We only have ourselves and our one example of physics. And we don't know. It's possible that there's another way to describe the universe, that essentially is an alternative explanation. And you might think, but come on, there's always got to be one simplest one. But think about when you have data, you have a few data points and you try to describe it, there's a lot of different ways you could draw a line through those data points. You never have infinite data. And even if you had infinite data, there would still be other theories you could use to describe that same data. And so it's an open question whether there's an alternative theory of physics out there that could be as effective as ours and yet not be just like a one-to-one mapping.
One-to-one, yeah.
Yeah, as the philosophers say, just another version of our theory, but dressed in different clothing. And as you say, we have examples of this sort of here on Earth, where we have two different descriptions of gravity, and they tell different stories. Not just that the math is different, because in the end, weak field general relativity does reduce to Newtonian physics. But they are telling different stories about what's real out there in the universe. And that's the exciting thing about physics, is the philosophical implications, right? To say we are describing the universe, but we're also revealing what's true about the universe. We know what's happening. This idea that spatial curvature is a real thing. I can't feel it. I can't sense it. Where is the curvature, right? I don't see it. I see its effect on stuff. It's always indirect. In the same way that we don't know if fields are real, right? The concept of an electric field is an idea in our minds that we think might be out there when we're not looking, but we don't know, right? This is a philosophical assumption we're making, or a position we're taking at least. And there's lots of philosophers who argue that there could be alternatives. And then, of course, this is a big argument in philosophy. There are philosophers who argue back, say yeah, but show us one. Prove it. You don't have another theory, so shut up. And the point is just to say that we can't declare confidently that there can't be one. Yes. There's no proof that there can't be another one.
Yeah.
And so therefore there could be another one. And it could be that when aliens show up, they are not following the same trajectory as we are. They're climbing the mountain from a completely different direction. And they're using very alien concepts. And, that would be fascinating, wouldn't it?
And that's sort of really, it would indeed. And that's a really nice segue into, because I was going to say, secondly, why might the aliens have arrived at a different formulation of physics? Because it seems almost inevitable that they would, right, with different senses, with a different cultural context, with a different history. It's very seductive to suggest, you do the Newtonian gravity, and then you go,
Yeah.
you naturally progress, and then you get your thermodynamics, and then you get your
Mhm.
QFT, and now we've got gravitational waves, and this is a nice kind of folk story. But there were a hell of a lot of dead ends, misses, doing ridiculous things for a long time before we
Yeah.
reverse gears. We see this folk history as kind of, an obvious, linear path forward.
Right.
But that's not
Right.
what we had on the Earth. And so it seems inevitable that aliens would have had different dead ends and
Mhm.
would have a different history of physics, and therefore a different formulation.
Exactly. It's not like our science is super well organized.
Yeah.
People like say like, it's a monolith or whatever, but like, no, it's a bunch of random weirdos, looking in different corners because they're nerding out about whatever they're excited about. People playing with patterns and numbers 100 years ago came up with ideas of group theory that most people thought were like totally useless and like just of interest to math nerds until a few decades ago, people realized, wow, this is actually the underpinning of everything we need for quantum field theory and modern particle physics. And
This is why I'm still happy
describes
for
the
them to be
universe.
messing with string theory, right? Like,
Yes,
it's always
exactly.
useless until, it's the explanation of everything we need, and now suddenly everything that was done is progress rather than a waste of time. And anyway, park that.
Yeah, no, I completely agree. And, I think it was Steven Weinberg who said it's positively spooky how the physicist finds the mathematician has been there before him or her, right? Like it's true, and that's amazing. But it's not well organized, and it's sort of a random search through the space. And there, as you said, there's lots of dead ends, and we mostly tell the story of the one path from the beginning to here, as if there were no other branches, but there were lots of them, right? And lots of dead ends, and we're still maybe going down some dead ends. And so it could have happened in another way. Even if you assume that like aliens are interested in the same stuff as us and have exactly the same, senses, and that there is one truth out there, we're not guaranteed to be on the same path as them. It could be that we're on very different paths because they took a very different tack from the very beginning. And so in the book, I did kind of a deep dive in this, and I wondered, like, what about just on Earth? Forget the aliens. Imagine the scenario where you have like 100 Earths. How would science develop on those planets? Like, is it inevitable the way we go from, astronomy and math, to our science? Or are there lots of different ways it could have gone? Like, even just on Earth, right? All the randomness.
Well, we think about all the kind of serendipitous discoveries we make, or it's just somebody, randomly in the early stages tinkering around in their back room. There's many
Exactly.
different ways that could have probably, somebody could have stumbled into that if you reran the simulation many, many times.
And to take a concrete example, look at like the discovery of radioactivity. Essentially, this is like guy with uranium,
Leaves it in his
leaving it
desk
on,
or something.
yeah, over the weekend. And because it was cloudy in Paris that weekend, he wanted to do this experiment where he left it out in the sun. He thought uranium absorbed sunlight and then emitted, but it was too cloudy. So he left it in his desk over the weekend. And then when he came back, he hadn't done his experiment, but he still, for some weird reason, had this hunch, like, let me develop the plate anyway.
Yeah.
And that's how he discovered essentially radioactivity, which kicked off the quantum revolution and could have been done 100 years earlier.
Yeah.
And what if it had? What if we had another 100
Where would we be now with another 100 years?
Right, exactly. Would Einstein, having grown up being taught quantum mechanics as a child, have developed a classical theory of gravity or gone straight to quantum mechanics, straight to quantum gravity? Who knows? And it's one of these, go back in time and kill a butterfly situations. the amount of changes could be enormous. It could be dramatic. And so even just that question, when aliens show up, they could be working on very different things. They could be puzzled by things we find easy. They could be
Yes.
very far advanced on things we're struggling with.
Yeah.
That also would be fascinating, but we should be prepared for all these different kinds of things.
And this is what we see in sci-fi as well. I think, again, I make no apologies for it being Stargate all the time, because that's my favorite. But, there are examples in there of there's a civilization called the Tolan, and they're basically 500 years ahead of the Earth, and they have all their spaceships and all of these, space lasers and things. And the only reason apparently is that they didn't have a Dark Ages, right? They didn't have an Inquisition, and they didn't have this kind of several hundred years where science was heresy in the middle of civilizational development, and therefore they're way off into the future. There's many different ways that things could have developed, could have gone politically, scientifically, sociologically, that would have changed the outcome that we see now.
Yeah, exactly. And that's really fun to think about because it makes for very different kinds of meetings of the minds. And I think something else that a lot of people don't appreciate is that not just the ideas we have from science, but the process of science itself is something that we have been developing for a long time. It wasn't just like an idea in the minds of Galileo and Bacon 500 years ago, and is still developing. It's still changing. We think about science as like, okay, we unlocked science and now we're going to science forever. But it's not like a step function. Think about the way science was done 500 years ago and think about the way it's done today. Like we didn't even have the word scientist until something like 150 years ago. We certainly didn't have a job. Like we imagine that if the aliens come, we'll send our physicists to talk to them. But like, who are they going to send? Do they have physicists? Is this like a thing you do as an alien? Is everybody out there a physicist? Are some of them like, a few hundred years ago, we would have sent our priests or our mayors or something to go talk to them. And, think about how our science has evolved. Like we have whole new regimes for the way we do science. Like it's not just theory and experiment. We have like simulation now, which is so much of our science relies on simulation. We can't even imagine making progress in many fields without simulation. So what have the aliens added to their sort of portfolio of ways to figure out the secrets of the universe? They might look at our whole method and be like, y'all are still doing that? Oh my gosh, that's so backward and basic, right? And so I think we should appreciate that, like, not only could they be more advanced in the process of science itself, but the process itself could be very different. It could have gone a completely different route. They could have a very different relationship with this process of like revealing truth about the universe. And so imagining that like aliens come and they do science and that they have scientists and we can all talk to each other, I think is reflective of just projecting ourselves out into the universe and not really being open-minded about how aliens could be.
Yeah, you jumped a little bit ahead in my questions, which is absolutely fine. But yeah, as well as talking about, physics isn't just a bunch of, numbers and theories and laws. It's also a process of actually doing the physics. And there's no reason that they would have to do it the same. Like you said, just think about our history. We go through the Greeks. You've been looking more at the philosophy, but it's sort of people talking about their experiences and trying to work out what's going on around them. And then you go kind of through, Ibn al-Haytham, who's probably thought of as one of the initial scientists who's doing, drawing diagrams, trying to do experiments, these kind of things. Later on, we kind of bring in peer review, this kind of thing. There's no guarantee that this is the ultimate way of finding truth, right? I think even now, you think about things like when people talk about string theory, they talk about the symmetry that we see in natural laws, but where we can't necessarily get experimental confirmation because these things might be too high in energy, so we can't build the experiments. And people have even had discussions even recently about, should we change the scientific method? Should we be thinking more about the beauty of the maths and how it holds together to be able to make discoveries? So this is not something where we've just even stayed still ourselves. We thought, should we upgrade this process? So it would be strange if the aliens turned up and just said, oh yeah, I understand exactly what you're doing there. What's your hypothesis? Show me your data, reject hypothesis. Let's go back. It doesn't make sense that would be the case, right? Because we're at an instant in our development where we've said, this is the gold standard. This is brilliant. But, a couple of hundred years ago, it wasn't. And in a couple of hundred years, we might have a a totally way of a totally different way of thinking about how to get at quote unquote truth.
Yeah, and I don't think even humanity has agreed on what is the gold standard for how to figure out the universe, which is why we have these continuing arguments like, is string theory physics or not? And
Yeah.
you might say like, what does it matter? Like, well, it matters because whether we're going to support it or not, and whether it gets included in physics departments and all this kind of stuff.
Yeah.
But it also matters because it tells us how we're figuring out the universe. And if we can't even agree among ourselves about what science is, and how can we expect to overlap it with the universe, overlap it with aliens, right? That they would be doing it the same way that we do. It seems sort of naive. And so, sometimes when you unpack these questions, you're like, oh, obviously, of course, this could be different. And that's a sign that like we need to be like looking at our assumptions and making sure that we're always asking that question, because sometimes all you have to do is ask before you realize, oh wow, yeah, that is an assumption, and I hadn't thought about it that way. And frankly, I think in this area, biologists are ahead of physicists. Like, biologists have done the work. They've imagined like how could life be different on other planets? How could the biology work differently on other planets? Relative to Earth. Because, for example, like on Earth, all of life is carbon based, but they don't just then assume, well, life has to have carbon in the universe. They think about other ways it could work. Maybe it's silicon, or do you need water to have life? Maybe you could have ammonia. They've done this kind of like break out of the box of our assumptions. And I think physics needs to do a little bit more of that to think about these things. Yeah.
Very, very interesting. So one thing I wanted to get to. So we talked a little bit about how the aliens almost certainly will have a different formulation of physics, and it might not simply be a relabeling of human concepts with alien words that we require to understand them. But surely these alien formulations would have to be heavily constrained, right? After all, they would have to encode, fundamental relationships between variables, whatever they call those variables. You would have to have some idea of E equals mc squared if you want to fly across, the universe. You would have to have some idea of entropy. You would have to have, E equals half mv squared, whatever it might be. Is the Rosetta Stone to understanding how aliens formulate their physics, not talking about the base units, but talking about these relationships? So I know you're very big in your AI, in your machine learning. Would it not be to kind of get what they're talking about with physics and try and find these patterns which encode E equals mc squared, which encode, S equals k log w, that encode, F equals ma? Would that not be the best way to go? So they might not use fields, they might use, rotating whatever they have, or vibrations, or who knows, God knows what. But there would have to be within those frameworks the encoding of that relationship at some point if they're solving similar problems that we have, which, okay, might not necessarily be the case, but let's say in the extreme, when we get towards, flying across space to meet each other, they're going to have to encode that E equals mc squared somewhere in what they're doing, however alien and odd it looks to us. Is that not the way to proceed? Because it seems like that's kind of, with the golden plates and things, that kind of what they were trying to do in a very simple way was, take these base units, which are almost certainly going to be different, but then try and show relationships between those bases. That's kind of the idea that we're getting at, right? That's where the good stuff lies. That's where the underlying physics relationships lies. What do you think about that? That the Rosetta Stone is really the relationships between their variables, however they define them.
Yeah, it's an appealing approach, and my point of view, I guess, the point of view of the book is to ask like, well, what assumptions are you making when you take that approach,
that, yeah.
and let's see what we know about those. And like number one, you're assuming, I think, that there's a mathematical way to describe the universe, that the language somehow is mathematical. Maybe they have different symbols, but that these mathematical relationships are the same. And if you want, we can go down the is math discovered or invented rabbit hole. But I think there's a bigger issue here, which is you're focusing on one part of the universe and you're saying, look, this is a relationship we've discovered that they have to also discover.
Mm.
But remember that every relationship we've discovered is not necessarily a reflection of what's really happening. It's our approximate description of it,
Mm.
even down to general relativity, which we know is not a perfect description of reality, right? It ignores quantum mechanics. It can't be exact. And if it's not exact, then how can you claim that it's true, right? It's a description and it's
Mm.
could just be one approximate description and not necessarily the only approximate description.
Mm.
And something that amazes me about the universe is that these approximate descriptions ever work. Why is it even possible to say F equals ma or E equals mc squared? Because if we think that the universe is fundamentally there's some like base layer of reality and there's bits and bobs and they to and fro and from that emerges our universe, why isn't it all just chaos? Why isn't it so complicated that we couldn't even understand it? Like I have a hard time modeling three objects moving. Why can I model 10 to the 29 as they fly across my backyard? There's this incredible thing that happens almost like magic.
Yeah.
We call emergence, where you zoom out and a different set of
Yeah,
laws
yeah.
now
A
apply,
different
right? At the
effective sort of
macroscopic.
field theory sort of
Yes.
yeah.
And we don't know how to connect them either. Like nobody knows how to go from, Schrodinger equation on 10 to the 29 particles to F equals ma. And so why is that even possible? Nobody knows. Why can you make, as they say, chicken soup without knowing quantum gravity? And so we don't know if this is something that happens because of a feature of the universe
Mm.
itself, like there's something that's happening there where things average out, et cetera, or if it's part of our human lens. And we've said, you know what, this bit is interesting. And so we're going to draw a dotted line around it. And then we're going to make our best effort to extract a simple scientific approximate story that ignores things we are not interested in and focuses on things we're interested in, and then gives us a useful tool. And in that sense, we're not describing reality. And somebody else coming at the same universe could be like, well, that's cool, but I'm interested in this
Mm.
bit of stuff over here. And I'm going to tell a different story, which works. Neither of them are true. They're both like two just approximate descriptions of different parts of the universe. And so, even if you assume that math is the language of scientific understanding across the galaxy, which I don't think there's data to support, and we can argue about it if you like. Even then, I don't think that we're guaranteed to find the same relationships, which I think was your question, because we don't know that the same stories will emerge for them as for us because we don't understand emergence. Like philosophers cannot explain why this happens. Some of them think, oh, it's a product of bubbling up from the microscopic bits. Others think like, no, what if you have different layers of zoom and each have their own fundamental laws, right? And the reductionist in you is like, no, it has to come from the
Yeah, it has
smallest
to
bits.
be, yeah.
Well,
Bouncing
why?
off each other or whatever. Yeah.
Why does it have to come from the smallest bits? Why this preference for small things over big things, right? That's just a philosophical assumption. It makes sense. It's worked really well for us so
Mm.
far, but that we don't have data to prove that it's the only way.
Mm.
And frankly, there's been a lot of failures. Like we can't often go
Yeah.
from microscopic to the macroscopic. You can't use the standard model to predict the path of a hurricane, right? It's useless. And there's a few cases like the ideal gas law where you can actually go from micro to macro
Yeah.
and derive laws,
Mm.
and it's incredible, right?
Yeah.
To see those equations emerge from the math is like, whoa. But usually you can't. And so
Mm.
we don't know why emergence happens. We don't know if the relations that we are discovering are fundamental and true and universal, or just sort of like a bit of understanding amidst a swarm of chaos.
There's a really kind of interesting side conversation here as well, isn't there, about what is real? So real
Mhm.
isn't even necessarily the base units we use, right? Like,
Yeah.
is an electron real? Is a photon real? Because you don't have to use photons or electrons in a framework to explain the universe. You just need to, be able to encode an interaction like Compton scattering, if that's what you can see, for example. So I'll put that question to you. Are electrons real?
Are electrons real? I love it because your audience is gonna be like, if this guy says electrons are not real, then he's like crazy.
I know
or
this
he's
bubbles
high
up on
or
Twitter every
whatever.
now and again, and people are just like eye roll and are like, off you go.
And
Philosophy
like
has turned up. in the silence
I'm like,
spectrum.
look, it makes a lot of sense to say electrons are real, and we built like a whole collider smashing electrons into positrons. What does it mean to say like electrons are not real? Are you crazy? Are you just being contrarian? Like, if you spend too much time in the philosophy department,
Yeah.
and
Oh,
so
you've definitely done that. Like, but we'll park
that's
that.
clear. Yeah,
Yeah,
that's
yeah,
clear. I've
yeah.
been
That's
bitten by
that's
that bug for sure. And it doesn't mean that like, LEP was a phony or, electricity isn't real or anything. Like, you can definitely charge your phone regardless of what happens at the end of this conversation. It's just a question about like what's there that we're not looking at.
it doesn't
Do
have to be a
electrons?
little ball like we see it
That's
as, right?
right.
It's
Yeah.
something with properties that goes into
Hmm.
our mathematical description and gives us useful predictions, but it doesn't have to be a little ball or a little wobble of a field that's whizzing
Yeah.
around in reality.
That's right. And if you press particle physicists, what is an electron or what is a particle, and you ask 10 of them, you're going to get 10 different answers.
Yeah.
So if you're like up in arms about how, like, yeah, obviously electrons are real, well, what are you talking about when you say an electron? Is it, an object that transforms according to this Poincare group? Is it a ripple in a quantum field? Is it a point particle? Is it something else entirely? Like, who knows? And wow, I love that picture. And so, is an electron real? Depends on what you mean by an electron. Obviously, it's very effective in our theories,
Yeah.
and it would be silly to exclude it. But if you mean, do electrons exist when we're not looking? Well, we don't have data to prove that.
Or
That's a
would aliens
philosophical
even
question.
formulate in that way of, having these point particles, which we then can
Yeah.
describe as wobbles of fields? Would they even formulate in that way? Could they get to the same physics of Compton scattering or weather without that?
Yeah,
Maybe.
and let me make a concrete argument on the other side. If you're like, this is all hand wavy, what are you talking about? Like, what do we mean when we say the electron? We're talking about the matter particle, right? Itself. And we know if the electron interacts with other electrons and it makes electric fields, but we're talking about the particle at the heart of that, right? The bit of stuff, right? But it's actually quite complicated to separate the electron from the bit of from its interactions, right? If you like zoom in on an electron, what do you see?
Yeah.
You see
What
a
is it
cloud
doing when
of
it's not
photons.
interacting with a photon in a Feynman diagram or whatever?
Exactly.
What
And
is it?
an electron, you can't actually separate an electron from the photons. If you try to zoom in on an electron, you see a cloud of virtual photons surrounding it. And the more you zoom in, the more you start to see nonsense. And if you try to penetrate that cloud and get all the way down to just what we call in theory the bare electron, you get a nonsense object that has a charge of negative infinity.
Yeah, we
So that's
have
not a,
to play with our renormalization and all this kind
yes,
of bare
exactly.
charge or yeah.
Exactly. And so what we actually call an electron, right? What we talk about, we measure in the lab, the renormalized objects, as you say, is not an electron. It's an electron plus a bunch of
Yeah, plus a bunch
photons,
of
right?
clouds around it, yeah.
And yeah, and so what that means is that our idea of the electron is like an arbitrary dotted line we've drawn around some stuff. It's a distinction we have imposed on the universe, not the one the universe cares about at all. This idea of an electric field, an electromagnetic field as being separate things, like that's
Which probably
arbitrary.
tells us immediately that our quantum field theory description is not complete, right? Is not the final
Yeah.
answer of
Yeah.
the
And there's lots of arbitrary choices. The way we used to like separate electricity and magnetism as totally different things. And later we realized, oh, that's just a dotted line we draw across something that, is obviously one phenomenon in the universe. We historically ran into it in two different ways and then later clicked it together and like, oh, that's so satisfying. It makes much more sense this way. But still, we draw a dotted line between it. People talk about electricity and magnetism. And so there's lots of places where we have defined things in a way that makes sense to us or just historical accidents. So, like, what is an electron? Well, you can't define it without a photon, point is my point. And you can't define photons without the W and the Z boson, but you can't define without the Higgs boson. And so, like, what is an electron? It's the whole universe, man.
You turn into what is it, John Wheeler, where he's only got the one riding along. And
Yeah,
anyway, we'll
yeah,
park that.
exactly.
I have
And,
two more questions. How is your
mhm.
time looking?
Yeah, I got 15 minutes or
Okay.
14.
Oh, all right. We're good then. Sorry, were you going to say something extra there? I just didn't want to. I just wanted to check on your time.
I think the harder that you look into these questions, the more you realize we don't have solid answers for them. And it's easy to be glib and be like, that's philosophy. But, this is underlying everything. And when the aliens show up, it's the philosophy that's going to matter.
That's very deep. That's very deep, Daniel. Was it intended to be? It was. I got chills. That was good. So I wanted to change gear slightly. So we're asking whether aliens can speak physics. I think in there goes a very related question of whether they would want to speak physics, right? So I'm also interested in this idea of
Mm,
whether aliens would want to speak physics. Would it be possible for a technological society to be completely incurious? Would it be possible that they don't place much value in physics at all? So
yeah,
when I think of physics, I think of a
good
way
looking
of
people.
understand. Yeah, I think of a way of understanding the universe. I think of people getting Nobel prizes. I think of people that we
Mm,
turn into kind of culture crossing celebrities for the way that they've done this. I think of ways that we could understand the universe, and therefore maybe we can get off this planet when it dies of climate change. And we tend to think, or at least I think the people who would interact with aliens would think, physics is a way of showing how advanced we are, how we're trying to learn about the universe, and therefore we have value. This is how much advancement we've made. And this is what you see in science fiction, right? You'll see, this civilization is clearly ahead because they're more advanced. This one is primitive and useless and unworthy and boring because, they're still crawling along the floor or, working the fields. So I just wonder if it'd be possible that you could meet them and they would just say, "Why do you want to talk about physics?"
yeah. Well, I agree with you. Physics is obviously interesting and fascinating, and all the best people I know are physicists, and they're all good
I'm the
looking and
worst,
charming.
probably.
Yes, and the worst. Um, and you got to ask yourself, like, well, why do we do physics anyway? And for me, it's about curiosity. It's about understanding the universe. And yes, there are technological benefits to it, and that's why I think we should fund it. But it's not. That's not why I do physics. I don't do physics because I want us to have faster chips and better phones and more effective death rays or weapons of mass destruction or whatever. I do it because I'm curious about the universe, and that's an emotional thing. That's my relationship with the universe. That's a desire to know. And are dolphins curious about the universe? Does the dog want to understand the universe? I don't know that it's necessary for aliens to have the same emotional relationship with the
Yes.
universe as
Yeah.
we do. And like,
Yeah.
what a projection to imagine that they must, right?
Yeah.
The other argument you might say is like, look, if they're technological, then clearly they must have figured out some science, right? But that doesn't really hold up either because we were technological long before we were scientific. We
Yeah.
developed bread and cheese and swords and all sorts of cool stuff without having any
Yeah.
idea how it worked. And probably a lot of people don't care, didn't care. Still to this day don't care.
Yeah, loads of
Most
people
people,
just, if my phone works, I'm
yeah,
sure, like,
or even
I couldn't
exactly.
explain to you, I couldn't build a phone. If somebody, I
Yeah.
sometimes think about this, have the sort of dream that, I'm transported back 500 years, but I have all this knowledge of modern physics. Like, could I make a good seed drill? Probably like not even, could I get people back through quantum mechanics and general relativity? Like,
Mhm.
probably not. Like,
There's a great book called How to Invent Everything by Ryan North, where he imagines exactly this scenario and how to recreate modern society at any point back in the past. It's an incredible book. But, this question of like, do aliens wonder why? Like as you say, when I cook in the kitchen, I don't really want to understand the food chemistry. I don't care. I'm not curious about that. And so to imagine the aliens have to be is really a projection. And you could imagine a scenario where aliens sort of stumble into technological discoveries through trial and error, the way we did for thousands of years. And I think maybe it's far fetched because obviously science is a huge accelerator in your technology, but it
I mean,
might
but
be that they just
what
don't.
if they're much longer lived? They've been around for much longer, or whatever. You can
Exactly.
imagine that it's possible.
In a billion years, you could stumble your way into warp drives, and they could show up and be like, "Hey, how's it going? We'd like to taste your cookies or whatever." And we'd be like, "We want to understand how the warp drives work." And they're like, "Well, here's how you build one." And we're like, "No, no, no. How does it work?" And they're like, "What are you even talking about? Or what does that mean? And why do you care? We showed you how to build it. Isn't that enough?" And it might be enough for them, and they might not have any understanding. And still, that would be a huge leap forward for us because, like, a working warp drive,
But
very useful. And
we'd like to reverse engineer them and be able to make
yeah,
more and
but would you
understand the
risk
concepts.
taking that thing apart? Like, what if you couldn't put it back together?
Yeah. Yeah, yeah,
But the point is that like this relationship with the universe is an emotional thing, and it's the reason why different people are curious about different stuff. And some people devote their lives to understanding like why beetles have this number of legs. And I'm like, I can't imagine doing that, but I'm glad that somebody is. I am, and no disrespect. It's a personal thing. It's a subjective thing, and to imagine that aliens would have to have the same interest and curiosity, I think that's science fiction.
you talked previously about, you know, if aliens had we have examples on this planet. If aliens had turned up 500 years ago, we probably wouldn't send scientists. We'd have sent a priest, right, to talk to them about, you know, how much do you know about Jesus, or, you know, Muhammad, or whatever it is. This would have been the way that we would have tried to work out, you know, how worthy, how much
Yeah.
understanding of the universe they had. I go to Stargate. You know, this race, the Nox, so incredibly advanced. They have all this amazing technology, but they basically just use it to stay safe, and then they just want to, you know, interact with the soil, interact with creatures, be very nice to each other, and treat everyone well, and
Target has
even-handedly.
really broadened your mind, Sam, hasn't it?
I know, right? Everything we were going to discuss, I basically just watched a few seasons of Stargate and then was like,
Did you watch Stargate? Are you a physicist because you watched Stargate, or did you watch Stargate because you're a
I
physicist?
think, I watched Stargate because I'm a physicist, but then I really liked it, so
Okay.
it's good. But you know, this is an incredibly advanced technological species, and you know, obviously the Earthlings turn up and are like, you know, how do you hide these? How do you make these things invisible? How do you, you know, hide your great city here? How does the city like float above the? And they're just like, why do you care? Like, you know,
Exactly.
just be nice to each other. Like, it's, and then,
Exactly.
and you have the situation, like I guess we would have as humans, which is they're incredibly frustrated with these beings, because they're like, look, we're trying to get technology to fight the bad guys, and they're like, what's a bad guy? Like, they're only bad because you treat them badly. And but the point here is their relationship to science, even though they're incredibly more advanced than we are, has changed, just like ours has changed over the years. And it doesn't necessarily mean that when the aliens show up that the first thing they're going to want to do is sit down and say, what have you done in physics? It might be something that's incredibly banal and boring to them, right?
Yeah. Yeah, exactly. And you know, it could be that the aliens show up and they're just wearing fuzzy purple pajamas like that, and they're very different, and they're not interested in the same kind of stuff. And you know, like most things with aliens, any answer is fascinating. Either the aliens show up and they're doing physics like we do, and we learn about the universe, and that's wonderful, or aliens show up and they're not interested in physics, or they're interested in different physics, or they've found a different solution. Any of those scenarios, we're going to learn something either about the universe or about ourselves. So I look forward to it either way.
Very good way to think about it. So last question, Danny, because I know you've got about 5 minutes or so. Here's your chance. The aliens have landed on the White House lawn.
Okay.
Rather than just telling them to come back, you know, in a few years when maybe Trump's gone, but we'll part that. What would your advice be regarding how best to try and extract the photon torpedoes, the teleportation pads, the warp drives from them? What do you think scientists should be doing now to prepare for this, and what should they be doing when they arrive?
I think everybody should read my book.
There we go.
You know,
There we go.
open their minds about the nature of the universe.
What
and
a
how
segue. That's a
might be
pro.
doing science.
That's an absolute pro there. Good. Excellent.
So everybody get a copy, read the book, buy one for your friends and your family, of course, your local library, all that kind of stuff.
Exactly.
Because I mean, joking aside, we do need to be open-minded about what they could be like and how they could communicate with us. And I think we'll have a hard task. So I actually asked the same question to Noam Chomsky, because I thought, who else has thought about like communication and how universal it might be? And that dude answers his emails. And so I emailed with him, and he actually came and had a conversation with me about it. And he said we should start with arithmetic, that starting with numbers is the right way to make connections. And like, that might be right. There are also people who argue that, like, you know, we don't know if numbers are part of the universe or part of our minds. And so we don't know that aliens do arithmetic. What if their bodies like aren't distinguished the same way ours are, and they like flow into each other, and the concept of integers isn't natural? But I think it's a good place to start. So I would start with numbers. and build up from there. Because from numbers, you can get arithmetic, and then from arithmetic, we can get all of math, and you can get Turing machines, and you can get programs and communicate more complicated stuff. So I'd say I'm thrown in with GNOME on this one and say at least try starting with arithmetic.
Excellent. Daniel, thank you very, very much. Again, we will point to the book. The book was out today, I believe.
Mm-hmm.
So you still might have to, fight your way through the stacks to be able to grab a copy before they're all gone. Available in all good bookstores, I assume.
Yes, and there's an audiobook version coming that I'm reading. It's not quite out yet, and it'll be there in a few weeks.
How could you turn those dulcet tones down? Guys, go out and grab yourselves a copy. Christmas just around the corner as well. For your science interested friends, this is a great pickup for Christmas. Daniel, thank you so much again. I really appreciate you taking the time. It's been very, very fascinating. Usually when I think about kind of semantics and philosophy, it brings me out in a cold sweat, but I'm glad you've made it interesting, relatable and exciting for us. So I thank you very much for that. And hopefully the sales go well, and hopefully next time there's something interesting in particle physics or the aliens arrive, we can get back together and chat again.
Sounds great. Thanks again for having me on, for being open-minded to all these crazy ideas.
I always try. Thank you very much, Daniel. Have a lovely rest of the day, and we'll talk again soon.
Wonderful.
Take care, buddy. Bye now. Bye-bye. I want to know what you think, because you're the scholars of enlightenment that I do this for. So please take a moment, if you wish, to let me know down in the comment section. And if you like this video, please consider leaving a like, subscribing, setting up notifications, and sharing this video more widely. I can't tell you how much these simple actions help me out and how much I'd appreciate it. Thanks for watching. Thanks for being scientific. Thanks for being bad.